Good morning. First of all, I want to thank you for your understanding during this difficult time. And I want you to know I do appreciate it. Today is the 7th of October. It's Thursday. As you may recall, next Tuesday, our usual class is going to be canceled due to the fall break. We will resume classes a week from today, which I believe would be the 14th. Also at that time, I will do some type of a review for the midterm exam, going over some of the things that you'll need to look for. And then also cover some of the material that we had talked about for week number 7. The midterm, however, will cover we will cover the first 9 chapters because that's the half of the material right there. Okay, so and again, that midterm will be a week from this coming Tuesday, and it will be held live and in class. It will be a paper exam. Okay, so I also want to remind you that we are going to be having you take a small quiz, 5 or 6 questions at the end, more like calculations, just to kind of show that you're comfortable with the numbers that we are doing today. So we're going to start now on slide number 20. I did add some additional slides to make it a little bit more understandable for you. At least hopefully it should be. So with that in mind, then let me move on from there, and we'll begin to share the screen. So again, this is we're starting now at slide number 20. So when we ended on Tuesday, I was talking about a concept known as discounting. And basically, it's where you're taking a future value and bringing it into a present value. You're going to see this more and more when we start to make decisions about maybe a piece of equipment that needs to be decided upon, A versus B. Equipment may have different life, periods. Some equipment may last for 10 years, some may last for 5 years. These have to be somehow calculated in, and the best way to do that is to do something in a present value state. So basically, doing the present value is like the reverse of the future value. The future value, you're starting with a number in the present time, and you are adding, or rather multiplying, some type of an interest rate. If it's over time, it is compounded, where you wind up with interest on your interest, and you wind up with a number. In the case of a present value, the number, you're going to start with a higher number and go lower. When you're doing a future value calculation, you start with a lower number and you go higher. So what's the basic equation for present value? Well, you take the future value and you multiply it by 1 divided by 1 plus whatever the interest rate is that you are working with. If you're doing it for multiple periods, you multiply it by an additional 1 divided by 1 plus whatever that interest rate is that you are working with. So you would do that, say, 3 times if we're looking at a 3-year period, or 3 period. If it would be 10 years, you would have to do that 10 times. So let's look at how this would break out graphically. So if your interest rate was 0, your present value would stay the same at $1 all the time. Okay, that's not really realistic, but this just gives you a comparison number. Now, you're going to find 2 things. First of all, that the higher the interest rate, the deeper the discounts you will get. okay? Because the higher the interest rate, the more that interest rate is going to generate your number to get uh, from the present value to the future value. So in addition to that, the further out you go in time, additionally, the lower the present value that you will be using. So let's look at this example here. You see 0, 5%, and 10%. And you'll notice that in this particular chart, we go out to 10 years. So at a 0 interest rate, the present value after 10 years is still $1. Okay. And by the way, you multiply that $1 by whatever the amount is that you're working with. So if it's $1,000 bond, you would multiply it by $1,000. On the other hand, let's say, for example, you are dealing with you're trying to discount something over 10 years at an interest rate of 5%. Well, in this particular chart, you'll see that 0.61 is whatever the present value of $1 would be, going from future value to the present value. So 61 cents today, invested at 6% per year, is going to be worth $1 10 years from now. At the same time, if the interest rate was 10%, then you would find that 39 cents invested at 10% over a 10-year period, 39 cents would move you to $1. Okay, so let's do some calculations and see how this will shake out for you. Okay, so discounting to determine present values. So in this example, the bank agrees to pay you $1,000 after 2 years when interest rates are compounded at 8% per year. So the $1,000 you're going to get 2 years from now. $1,000 is not today's value. $1,000 is the future value. What is the present value of that payment, given that you're using 8%? So using the formula that we mentioned previously, you take the future value of $1,000, multiply it by 1 divided by 1 plus 0.08, which is the interest rate. And then since it's for 2 years, multiply that number again by 1 divided by 1 plus 0.08, which is the interest rate. The result of this calculation gives you $1,000 times 0.8573, or $857.30. That is what $1,000 in the future, 2 years from now, will be worth today, given interest rates of 8%, $857.30. Now, sometimes formulas, in this example, this one's fairly easy, but as you start getting into more complicated formulas, there may be other ways that you want to do this. One manual way of doing this is by using a chart. There are 4 charts in the back of your textbook. 2 of them pertain to present value and 2 of them pertain to future value. So let's look at this again, but we'll use the appropriate chart in the back of the textbook. So a bank agrees to pay you $1,000 after 2 years when interest rates are compounded at 8% per year. All right, how do you use this chart? Okay, we know that we have an interest rate of 8%. We know that we have a 2-year period. So the 2 years are on this vertical axis over here. On the horizontal axis, we go to 8%. The two numbers meet at the factor of 0.857. So you multiply the 0.857 by the $1,000 and you get $857. Now, in our example that we mentioned, it comes to $857.30. Well, that number that has the additional 30 cents, that would be, that 30 cents occurs because with the chart that we've used, they have rounded it to 3 digits. If you rounded it, say, to 4 digits, these factors could very well include that 30 cents. So as long as you're very close to the number, that's all you're really going to need to worry about. The factors, the factor charts, they're generally pretty accurate, but if you have to get really precise, you might need to go to a calculator or to, say, an Excel spreadsheet. All right, so let's move on here. So what we're talking about when we're doing these factor tables is we're coming up with a number, a factor, which is then multiplied into a dollar amount that you are working with. So let's take another example. So let's say you have present value. What is the present value of $1,000 10 years from now when interest rates are currently at 8%? Okay. Now, the factor for this is 0.4632. Your answer is $463.20. Well, again, where did we get that? So if we go to the factor in the back of the book for present value of $1, you'll recall that we're still using the same interest rate of 8%, but now instead of 2 years, we're using 10% for the period of years. The 8% numbers and the 10-year number merge at 0.463 on that chart. So the factor is 0.463. We multiply that then by $1,000, and that's where you get the answer of $463. Again, if you rounded it up, this is a rounded up number. If the factor went to 4 digits, it would include the cents as well. Okay, so when we're looking at these factor tables, there are, and this is also true for a number of other type of problems when we're talking about working with present and future value. There are 4 variables: the future value, the present value, the interest rate, and the number of periods. Future value on a calculator or some other charts, you'll see the FV, that's future value. PV is present value. A lowercase r is for the interest rate, and N represents the number of periods. So if you know any 3 of those variables, you'll be able to solve for the 4th unknown variable. Okay, so let's look at an example. So let's say now we have $1,000 in present value. We know that at some point in the future, it's going to be worth $1,403. Well, in this particular example, we know that it's going to move from 1,000 to 1,403 in 5 years. So to go from one point to another within 5 years, there's got to be an interest rate involved. What is that interest rate? Well, if we look at the financial calculator, we would enter $1,000 for present value. We'd enter 1,403 for future value. The N number is, the N key is number of years is 5. And then we press, in this particular case, it's actually the I/YR key, the interest rate per year key, which is the same as the CPT. That's on some other calculators. That would give you an interest rate of 7%. So let me pull up the Hewlett-Packard calculator that we've been talking about. So the keys that you use for these calculations are in the upper part of the calculator. There we go again. N, I/R for interest rate per year, PV, present value, PMT is the payment, and FV for future value. So what you would do is, let's start at the beginning. So we have the present value of $1,000. You punch in 1,000. Now, with these calculators, when you are making an investment, the calculator looks at that investment as money going out. So any investment number going in has to be entered in a negative number, as a negative number. So you'll type in 1,000, and then there's this little key over here, plus or minus. That's at the fourth row down, all the way on the far left. It changes whether it's plus or minus. So if you have a positive number entered and you hit that key, it'll become negative. If you have a negative number already in there and hit that key, it will turn positive. So if we enter 1,000, hit the negative key, and you'll then hit the present value, the PV key for the present value. We do know the future value. The future value is typically going to be a positive number with using the calculator. So there you're going to enter 1403 and then hit the FV, the future value key. Period of time is 5 years, so we're going to hit the number 5 and then enter the letter where it says the letter N. The compound interest rate that we'll use to calculate this, you'll just hit the I/YR key, and that will give you 5. So it would compound, I'm sorry, 5 would be the interest rate of 5% that you would have over the, I'm sorry, no, that's 7% over 5 years. Let me just confirm that here. Yes, it's 7%. All right, so just to reiterate, N is 5, I/R is the number we're trying to find, negative 1,000 is the present value, 1403 is the future value. If you hit the I/YR key, you'll get a compounded interest rate of 7%. That's what we are trying to find. If you use the charts in the back of the book, you'll get a very similar answer. But you just have to know what you're looking for. First of all, you want to make sure you're getting the future value table. You don't want to use the present value table. And of course, the question is going to ask you or to give you the information that you already have. So we know what the present value is. That's the 1,000. We know that the future value is 1403. And we know that the time period is 5 years. So when we go to this future value chart, we know to go to the 5-year mark. The question is now, at what interest rate are we going to do? Well, we know the future value is $1,403. Okay, we know it's 1403. We also know that this future value chart is based on $1. So whatever factor is used, you have to multiply that factor by 1,000 in order to get the future value, which is $1,403. So that basically means that you would divide 1403 by 1,000, and that will give you the number of 1.403. And it just so happens that under year 5 and under 7%, you see the factor of 1.403. Okay, so that's how you would use the future value chart at the back of your book. It's the future value of $1. Okay, now let's say we're looking for other bits of information that are missing. Remember, if you have 3 of the 4, you can solve for the 4th one. So in this particular example, again, we know that $1,000 is the present value. The future value is 1403. And in this example, we're giving you the interest rate of 7%. So what length of time does this investment involve? If we use the financial calculator, we would be entering 1,000 for the present value, and again, hit a minus number because it's present value. Future value 1403. The interest rate key, which is I/YR for this Hewlett-Packard calculator. There you'll enter 7, and then you will hit, now this says the compute key followed by the N key. All you'll really need to do is to hit the N key. The CPT is for, I believe it's the Texas Instruments calculator. But for the Hewlett-Packard calculator, you just hit the N key. and that will give you the number of years as 5.01, which again, rounded to a whole number is 5 years. Okay, so and as you mentioned down here, some calculators may require either the PV entry or the future value entry to be negative. All right, so let's now look at, we're trying to determine here what the length of time is that this investment did. So we saw from up here using the financial calculator, and I think I'll show you another example of that in a moment. The answer we should get is 5 years. So we can get that also by using the future value table at the back of the book. Interest rate is 7%. We know that the present value is $1,000. The future value is 1403. We know that at some point that we know that the chart we're using is a future value chart of $1,000. So if it's worth 1403 in the future, that means that it's going to be, you divide the $1,000 present value by the 1403 future value, and you will get a factor of 1.403. Okay, so you look for 1.403 under 7%, and sure enough, on the far left table, the far left listing, you'll see 5 years in that particular column. Okay, and again, here we are. This is the Hewlett-Packard calculator. Using this here, you'll use you're solving for n. You know what the interest rate is, which is 7%. The present value would be a minus 1,000. The future value is a positive 1403. You will then hit the n key, and that will give you 5 years. Okay, now here's another quick method of determining how quickly an investment will double in value. It's a pretty nifty trick, and it's pretty accurate too. It's called the rule of 72. So this will give you the approximate time it will take in order to determine approximate time it will take given a certain interest rate, how long it will take to double your money. So the way that it works is this. You take the number 72. If interest rates are 6%, you divide 6 into 72, and that will tell you that that investment will double in 12 years. 72 divided by 6 equals 12, or 12 years. Additionally, if you're trying to determine the interest rate, you can do that by just reversing the numbers. If you divide 72 by the number of years, which is 12, you'll know what the interest rate is, and the interest rate will be 6%. Now I have 6 years there. Okay, what that really should be is that should be 6% right there. Okay, so that's it for this portion right here. So I'm going to stop here, and we'll start another session in a moment.